In this session, we'll study the power system control concept. The objective of power system stability studies, either it may be a steady state or a transient stability, the main objective of a stability study is to determine whether or not the rotor of the machine is being perturbed and return to constant speed operation. Obviously, this means that the rotor speed must be depart at least temporarily from the synchronous speed, and once again they are settled to the pre-described values. To make the system stable or make the overall system to increase the overall system stability, you have to take appropriate the control techniques and the transmission system design concept. That is, to increase the overall the system stability, one should have stability control techniques for the power system as well as the transmission system design. The factors to determine the instability form which causing the instability, they are listed here. One is the size of the disturbance. If the disturbance is very large and is prone to the instability, and physical nature of the resulting instability, that is the physical, the effect, or there is a the the tree is fallen the transmission network, it is disrupting the whole the transmission network. That is the physical nature of the resulting instability. And the third factor which is causing instability is the dynamics of the power system, that is the dynamic structure of the power system. And the fourth important the fact which prone to instability is the time span. That is, if the fault is the lasting for a longer time, then definitely there is a large deviation of the rotor angle delta, then it may cause to instability. These are the factors which determine the instability. Therefore, each instability form does not always occur in its pure form. It is not this is a listed one. It is in the form. It is related to these things. One may lead to other, and the distinction may not be that clear. Okay. Then the disturbance which is on the power system, it is affecting the system parameters. That is what we are calling as fault on critical element. These are, that is the disturbance which is causing, there is a bus voltage deviation, there is a power flow variations, and also it is affecting the rotor speed changes. Ultimately it is affecting the system frequency. These are, there is variations in the voltage, power, and the rotor speed because of the disturbance in the power system. If there is a change in the voltage or a bus voltage variation, then what you have to do? You have to actuate generator voltage regulator in the generator side. You have to actuate the transmission network voltage regulator for the appropriate the corrective measures in that particular area. That is, a voltage regulator is the heart of the excitation system. The output voltage of the generator changes only when there is a voltage regulator instruct the excitation system to do so irrespective of the speed response of the exciter. That is, the regulator sends the changes in the output voltage and cause corrective action to take place, so that once again the steady voltage is achieving at the different parts of the circuit. Then ultimately you are this is because of the bus voltage deviation, there is a system voltage variation that is the counterbalanced by actuating the generator and the transmission network voltage regulator. Then if it is not possible, then if you are not making appropriate action, these actions, then it is affecting the system load as well as respond of the protected devices to take the appropriate measures. Under power flow variations, also there is a responder of protective devices. If there is a variation that is detected, and you have to make appropriate corrective actions. And the rotor speed changes also and actuate prime mover generator control so that the deviation of the angle delta should be minimized. Then otherwise there is a change in the system frequency variation, then it is also affecting the system load. Ultimately the effect of this the disturbance because of change in the bus voltage variations, power flow variations and rotor speed changes, then the degradation of the power system, that is prone to the degradation of the power system performance as well as instability. These are the causing the instability because of disturbance, because of variation of the voltage, power flows and the rotor speeds. So that then how to counterbalance them? You should not go into the instability conditions. You have to control these voltages, power flows and the rotor speeds in the event of disturbances. Therefore, you have to take the appropriate the corrective measures in the form of the controlling these things. Therefore, when there is a disturbance occurs on the power system, it should be sensed and there is a continuous control in the system that is monitoring the changes in the parameters, and appropriate controlling system will take, and it is once again it is maintaining the parameters of the system into their prescribed values. Suppose if there is a very large changes there occurs in the system parameters, then the appropriate protective the release they are sensing those abnormalities, and appropriate protective action should be taken so that system is remains in stable condition. Then for this we need the network data. This is how we are controlling the power system to maintain in stable condition. Then this continuous control, what I shown here as in the three different levels, the generators level as well as the transmission level as well as the distribution level. In the case of the generation level, we have got a continuous controls in the form of generator excitation control, in the form of power system stabilizers and automatic voltage regulator. They are controlling the, if there is a variation in the voltages and it is sensing, then you are increasing the excitation so that you can maintain the voltage profile at the different buses. And if there is the changes, and the appropriate action should be also be taken from the prime mover controllers in the form of increasing, if there is an increase in the load, if there is a fall in the voltage because of more load, in that case there is an input to the generator is increased by prime mover controller, so that once again you are maintaining the profile of the voltage at the prescribed values. And other the controls relating in the generators are reactive power control and HVDC controls, that is in the generator stage. Similarly, in the continuous controls in the transmission network are as categorized as discrete supplementary controls, special stability controls and emergency control and protective schemes. Under this control, discrete supplementary controls, that is helping the generation control by giving appropriate the feedback to the excitation system as well as the prime mover controllers. But in the case of the continuous control in the transmission system, the more important the continuous controls are emergency control and protective schemes, because here in the transmission system the variation of the system parameters is basically because of the large fault occurs in the system. Okay, because of that you are very careful about the emergency control and the protective schemes such as relays, circuit breakers and all those things controls. And in the case of the distribution level, we have got switching capacitors and the reactors, tap changing and phase shifting transformer, HVDC control, synchronous condenser, static power compensator. These are they are using for improving the power factor of the distribution network as well as the voltage profile. They are feeding into the reactive power. That is a leading factor. Different methods by either using synchronous condension, condenser, static power compensator, and the switching capacitor. All those things they are helping to improve the system voltage and as well as the power factor of the load. Controls at a different operating stage, its a main objective is to return the system in off to normal operating state to a normal state. That is, in the event of a large disturbances, if the system is changing from one normal state to the other state in the disturbing mode, then our objective is to bring back to the normal. Then what are the different operating states you come across in the power systems? The some of the operating states that are is listed in the literatures are: one is the normal state, that is the steady state condition. In that case, the system parameters is not changing, they are constant. In the alert state means there is a change the some the conditions, system parameters in the normal state. If there is a disturbance occurs, it is goes to the alert state. Means there is a change in the system. Therefore, a small continuous controls will be takes place and once again you come back to the normal state, the power system. Another state is emergency controls. In that case, very large changes they are occurring in the system. That is, a disturbance is occurring in the system, and the operating state from the normal steady state to it is goes to emergency, where there is an imbalance is much. There is a lot of variation in the system parameters. Then our objective is to control this. Just as you have to bring this emergency state of the power system back to the normal state. That is a severe case. In the case of extreme is a extreme case where the change is abnormally very high. In that case, if you are taking the switching actions, if you are cutting out of the faulty point, and if you are immediately if your action is taken, then it may you are bringing back to the normal state. Otherwise, in this case, the system is goes into unstable condition. Restorative state is it is a possible to, even though if there is a disturbance occurs, then it is by appropriate control of the variation in the inputting the more excitation, automatic load frequency control, and generator prime mover controls, and if it is possible, then the system is bring back to the normal state. These are the different states that will come across in the power system in the event of a disturbances. The normal state means it is steady state conditions where the system parameters are constant. That is, in the emergency control, in the large disturbances, the normal state is moving into the emergency state. Then if you are taking a small appropriate the controlling action, then slowly emergency state is converting into restorative state. Some after some time, then it will bring back to the normal state. Okay, this is how there is a cycle. Then in the case of a normal state, very small changes are occurring, it is goes to a restorative state, and by appropriate controlling, it is once again bring back to the normal state. Then the power system controls are usually that is a normal and preventive actions, that is control for the normal and alert states, that is a control for the normal and alert states are, that is you are stated you are divided this normal and alert state. Here the change is very small, that is the disturbance is small. In that case, you are going for automatic frequency and voltage control as a control elements. Whereas in the emergency control, for emergency or extreme state, that is UFLS, UVLS, and special system protection plans are planned for bringing the system to the normal state. In the case of the dynamic and the control time scales, that is to what is the interest of studies in the terms of a time scale. that is a rotor angle stability as a short-term stability problem. That is, it is concerned with the generator side. Here, if there is a large disturbance occurs, there is a variation of the angle delta is large, then stability studies as in the your study within very short period of time, that is 3 to 10 seconds, and you have to take the appropriate the corrective measures here. Under the rotor angle stability itself, in the case of a small disturbances or steady state stability studies, the study period is around 10 to 20 seconds. And whereas the voltage stability studies, it is concerned with the load, then it is a short term or a long term stability production. Therefore, the interest of studies goes from few seconds to several minutes. Whereas the frequency stability studies, which is concerned with the load as well as the generator, load and the generator. Therefore, a long-term stability problem, it is a long-term stability problem. It is lasting for few seconds to the several minutes. And post system time scales. The study of the time scale is very, very important so that the system may be remain in the stable condition. That is a lightning propagation. That is it is a very, very short time, that is 10 raised to minus 7 to around 10 raised to minus 3 seconds. That is, you can see the time scale here. Within that time, you have to make all the analysis, and you have to take the appropriate action to make the system to remain in the stable condition. That is, in this case, lightning propagation. We know that we are using the lightning arrest as soon as there is a lightning is struck on the system or a transmission line. Then the air gap between the lightning, the horns, that is get ionized, and there is a discharge will be takes place, and system may be protected. And the switching surges, it is lasting for 10 raised to minus 5 to 10 raised to minus 3 seconds, whereas stator transients and the subsynchronous resonances, that is SSR, they are concerned with the system dynamics. That is, the study is around 10 raised to minus 4 to around the 5 seconds. And the next comes your transient stability, that is a rotor angle stability. It is because of a large changes in the system. That is, the study is lasting for, that is, 1 second to 10 seconds. Whereas governor and load frequency control is from 0.1 to around 300 seconds, and then comes the boiler and long-term dynamics, that is voltage stability and power system stability, power flow. The system analysis is around from 10 to 10 raised to 4 or 10 raised to 2 seconds. These are the time scale in which you have to study and analyze the system, and you have to take the appropriate actions. These are some of the reference I made for this presentation. That is the definition and the classification of power system. So IEEE transaction appeared in 2004, and main reference for this all my presentation as the elements of power system analysis by Stevenson. These are some more the references.